Hello everybody, this is Ahmed Mukhtar, and today we're going to be discussing a failover mode known as active standby. Now there are basically two failover modes, active and active standby. Now active only works with multiple context mode of the firewall, which we don't have configured right now. We have a single context firewall over here, so we can only run active standby. That means one of the ASA box has to be active, means it will be actively receiving data, sending data. I mean, the works, whatever the firewall does, it does it. But the other guy, the other secondary one or the standby one, will be just standing by. Means if the firewalls, the active firewalls interfaces or itself, it goes down because of power failure or some sort of problem in the software. I mean, the software hangs or something, then only it takes over. So it sits there idle. Not exactly idle, but the keep lives are happening between them, but it doesn't accept any data packets. The data packets are being accepted only by the active one. So that's hence the name active and standby. Now I have topology over here, which I would like to go through first of all before we go into the lab. Pretty straightforward, nothing out there. For testing purposes, I have this. Whoa, this is the other slide. Let me take that. Yeah, this is the other slide. I wasn't actually going for that. I was going for a pen. Okay, blue will do fine. So I have an inside router over here, which will be used for testing the outside router. Means I will be going through the active firewall, whoever it is, towards my outside router and testing failover as we go through. So I have this kind of an inside, you could call it, inside zone, you could call it, in which I have an a subnet configured of 10.1.1.0/24. The VLANs that will be configured on all these ports will be VLAN 10 and will be access ports. I'm doing this because, I mean, for simplicity's sake, to get the baseline of the failover is the key of this lab. Okay, there are very, like a complex design that come up when you're inside the production environment. But the thing is, you should be ready for this because this one, what am I doing? So I've got my pen back. Sorry, I just hit a wrong button on my pen. Now I was telling you that there are very complex design in the real life, but the base concept is the same. Okay, so the series that I'm going to be using in the inside zone that I have configured over here is going to be 10.1.1.0/24. I'm just going to be giving them my IP addresses from the series 10.1.1.1 on the router, and the gateway on the router will be configured. Actually, I don't have a default gateway. I have a static route configured for this subnet only because I only have two subnets. I could have used default route if I wanted to, but it's pointing towards 10. Okay, just to put it out there. Again, we will see all of the details. And I told you these ports are access ports in VLAN 10 will be configured. And then I have these interfaces which I haven't actually configured. As of right now, they're blank. Actually, the firewalls are blank. Nothing has been configured on any of the firewalls. Ethernet 0 is going to be used for the inside, and Ethernet 1 is going to be used for the outside. Now, the thing to note over here is that I have chosen Ethernet 0 to be connected to this switch, and same Ethernet 0 is being connected from the secondary firewall to this switch as well. This is very important because when this firewall goes down, anything configured, any IP configured on this side, on this interface, will be replicated to this, obviously, and this will take over. And if you don't have the same interface configured, you won't have a failover. Okay, that's going to be a problem because they replicate each other's config. So the design must facilitate that as well. Same for that. Ethernet 1 going to the outside. I have already not configured, but already connected to the switch. And I'll be configuring VLAN 20, even though this isn't a private subnet, but still it works just for understanding sake. And I'm just giving it an IP address from this subnet as well. Well, that's pretty much it regarding the topology. Let me just show you one more thing. I've got this Ethernet 2 connected to Ethernet 2 directly, and this is going to be acting as our failover link. And Ethernet 3 is connected directly to the other firewall, the secondary firewall. This is going to be our state link. The main purpose of these links is that the failover link is mainly used for configuration replication. Means as this is a primary and active, hopefully, because the roles could change. Well, that's an odd way to write active, but still, if it's active, I'm doing the configuration changes on this active firewall. Now, whatever I do, it has to replicate to this firewall over here, the secondary firewall. So all the replication and stuff, the configuration replication is done by the failover link. Okay, one more thing, state link is used to do a lot of things actually, but the main thing, I'm saying things a lot. Main feature of this state link is, if you ever been to a firewall, you have definitely hit this command, show connections. So you have all these connections, these TCP and UDP connections going through the firewall that the firewall is maintaining the state for. Now, that state is replicated to the other firewall from the state link. It doesn't happen through the failover link, okay? The failover link doesn't they don't exchange states on that failover link. They must have a state link for that to happen. And it's very useful because if you have, supposedly this router has a TCP session going through the active firewall over here, and this guy goes down, the state table was synchronized between them. Now what's going to happen is this is going to take over, do some gratuitous ARPs on the ARPs on the network, and this guy's ARP table will be changed, and this will start going from this side, but the connection won't be dropped because it already has the state table that is maintaining inside of its state table. State has been maintained for that telnet session in its state table, and it's working fine. So you don't get that freezing kind of look. It means if you're doing an RDP somewhere outside, your RDP will freeze, your telnet might freeze or might disconnect, and you will have to reconnect it again. That won't be happening if you have that state link in place. Now, state link does a lot of other things as well, like ARP tables are exchanged through the state link. I'll just show you the Cisco documentation once we're doing the lab, what does it do, but it does a lot of things, and for a pure failover, I would believe, a seamless failover, hopefully, this state table is very key. You must have that in place. Okay, so finally we're going into the lab. This is the part I love. Actually, every network engineer loves this part. So here is the topology that I've created on EveNG. And as you can see over here, we have kind of like the same topology that I had over here, just some more details I have put in, like what will be the failover links subnet and what will be the state links subnet. So I've chosen the /30 subnet because it's smaller and obviously won't contradict in my network. You should first of all see if there's anything running from these subnets in your network, and you should be planning it and choosing these subnets effectively, because only two IP addresses are going to be used, one by the ASA 1, one by ASA 2. So you have to plan that a bit before you go for deployment. Okay, the routers have been configured already. The VLANs have not been configured. I'll just configure them and make them an access port. Yeah, so that's what I will be doing. I have all the sessions. First of all, let me show you the router, what I have configured. Simple, show IP interface brief, and IP address has been configured. Show IP route. A route has been configured for the 20 subnet. That 20 subnet is, one second, my mic is going down for some reason. Let me just pull it back. Yeah, that's much better, I believe. Okay. Okay, so okay, the route is there. And the switch, let's just look at the switch. It's a virtual switch, VIOS switch. So show interface status. It's all configured in VLAN 1. Why on earth are all of them are connected? I don't know. So there's something wrong with, funky things happen with Eve and G, truth be told, right? So there are a lot of these things happening with Eve and G. Show interface data. Let me check the outside firewall. It's also showing all is connected. I'm not sure why, because not all the ports are connected. Only 3 ports are connected. Anyways, it's your work. That's what I want. But there are gonna be some caveats, some deja vu happening here. Okay, sometimes with the switch it does that. And here is our ASA, and let me configure all these ports. Interface range gig 0/0 2, because we have 3 ports, 0/0, 0/1, 0/2. All of them should be in VLAN 10. So I'm just putting them in VLAN 10. Before I put them, let's just make them access ports. Switchboard host. What this command does is 2 things: explanatory port fast and makes them an access port, but doesn't assign the VLAN. VLAN will be the same. Switchboard, the same VLAN 1. Switchboard access, so VLAN will be 10. Okay. There wasn't a VLAN existing. Great. Show interface status. Now you see all the ports on the VLAN 10. And show MAC address dynamic. I'm only learning one MAC address from gig 0/2. This guy, because that is the only one configured. These are all in shutdown state because the ASAs don't have anything configured right now, but we are going to be configuring them. Similarly, I will go to the outside switch, which is this switch over here. This one. Yeah, this one. Interface range gigabit 0/0-222 switchboard host, switchboard access VLAN 20. So creating the VLAN. So write that as well. So okay, so I think we're ready now. Now we have this ASA 1 and ASA 2. We booted them up. Let's go into ASA 1 now. You don't need to configure both ASAs from really scratch, because really scratch, I said. It could be a case where you have this firewall already in place. This firewall, as you see, this one might already be installed on your network, and you are going to be installing a new firewall in failover mode. That could be the case. There are only a few commands that you need to do on the secondary ASA, and the rest you can do on the primary ASA, and that's it. Every configuration will be replicated from the primary to the secondary, but you have to do this carefully, because I've been haunted with this a lot of times, actually. 1 or 2 times, not a lot of times, but 1 or 2 times. What happened was that a blank configuration was replicated to a configuration that was already running, and what happened was not good. I had to reboot both the firewalls to put them back in their existing configuration. It was a very frustrating moment. It could have been for anyone. Anyways, okay, so let's put it a hostname ASA DC. So this is going to be the hostname of ASA 1. Now, the first thing what we're going to be configuring is the priority. The priority are 2 types, primary and secondary. Primary obviously has a priority, but you might be asking, what is the priority actually doing here? Truth be told, there is no preemption in the active standby design. You might be getting a little bit of flashback from HSRP or something, right? Active standby, primary, secondary, priority, all that, huh? So what happens is that whenever the 2 ASA firewalls find each other, okay, they call them mates. When they try to find a mate and they find each other, at first there has to be a tiebreaker between them, saying that, hey, okay, you are the primary one, I want you to take the active role. That's it. That's pretty much it with the primary and secondary one. So it's better because you are the designer and you want specific. I mean, the firewall are the same, but still you want the upper firewall in rack number 1 to become active, to become primary actually, because you want it to be the active one, and that may be the case. But if you have configured it accurately, even if they have been failed over or anything happens with them, like a failover, yeah, that's what I'm trying to say. If they fail over to each other, if the configuration and the design suits these firewalls in their design of failover, of active standby, nothing will happen. It doesn't matter which one has the active and which one has the standby role, unless and until everything's working fine. So, but this was the first tiebreaker, I believe, that you do this primary and secondary configuration. So let's do that. Failover. The command is, because I'm on the primary ASA that I have dedicated. Now I'm gonna make it primary ASA. But before that, let me just do a show run failover. Now I want you to always say this command is over there, because this is a switch, a kill switch. when you hit this switch, the failover process actually starts. It starts finding its mate, and like the election happens and whatever. All these things happen. All these things happen. You will see now. So this command should be there on both the firewalls. This is just my way of doing it. I mean, you could just ignore this, but I don't want it to start failovering and you're doing its stuff right now before I have finished my configuration. First, let me do the configuration, and then I'll hit this kill switch and enable failover. Not exactly a kill switch. I mean, enabling the failover. This is the switch, how it enables the failover feature on the ASA firewall. I don't know what. Sometimes I don't understand what I'm talking, but yeah, I don't know. Okay, failover LAN unit primary. This is a command that makes this unit a primary unit. Now I'm going towards the secondary unit, doing the same command, failover LAN unit secondary. Okay, so I've made this one the primary, this one the secondary. Okay, now once I've done that, now I need to first of all enable this link, this failover link. Without this failover link, you cannot actually configure this active standby or failover design. So this is the first thing that we're going to be doing. Now, normally you would actually go into interface and start configuring stuff, but here only what you need to do is go into the interface. First of all, let me show you the interfaces. Show interface IP brief. Now, there's a problem, I think, with show interface IP brief. What I do, that this was quite deliberate to show you that I just configured this ASA, which is the secondary ASA, with only 4 interfaces, and the primary ASA has 8 interfaces. Now, if you look at the documentation, let me show you the documentation. Actually, I forgot to show you this failover requirement page. I should have shown you this before, that the same model should, whenever you're doing a failover configuration on your ASAs, you should be of the same model, physical, virtual, same number of interfaces and interface types. Now, it's not like it's not going to do the replication or everything, but it's going to prompt you for errors. It has no interfaces configured that way. But the best practice is you must have the same number of interfaces, but I didn't do that. Do this best practice. Anyways, we'll see what happens. The same RAM should be there, same context, single or multiple. We have the single, that's why we are going with the active standby design. And same firewall mode, router or transparent. Router means layer 3 and transparent means bump in the wire. Same AnyConnect software in Flash. This is very important. Some people don't have the same AnyConnect software inside of their flashes. Now, the problem occurs is that whenever a failover happens to the secondary one, what happens is that AnyConnect stops working because the flash doesn't have AnyConnect software. So that software is not going to be propagated via the failover link as you see over here, it's not gonna go and install the software inside of this guy's flash. So if you have it, you have to install it in the flash via FTP or TFTP, whatever the case may be. So you're the one that has to do that. Okay. So we have not actually followed the best practice, properly, and I'll just show you what happens actually if you don't have the same interfaces. There's gonna be some errors, but I don't think that's gonna halt our journey because we are only using the 4 interfaces. Okay, but in the real world, never do that, because you could end up with a scenario where you have an MPLS termination or something is going to be terminated on your firewall via a switch or something like that, and you need both the connections to be terminated like this. And if you don't have any ports here, you have a single point of failure. So that shouldn't be like that. By design, it's not wrong. It is wrong. Coming back. Now we are going to be configuring the failover interface. The failover interface. Ethernet 2 is the failover interface. So first of all, we're just going to Ethernet 2 and just no shed it. Similar will be the case for Ethernet 3, which is going to be our state link. I'm going to no shed that interface. And similar for our secondary one, no shed that interface. 3, no shed that interface. Okay, it's not going to automatically no shed that interface. Okay, so show interface IP brief. So we can see that both are now up. At least they're up. They're not been configured for IP addresses and stuff. We're going to do that right now. So now we are going to be configuring all the parameters for the failover. Now you don't go inside the interface. It automatically just does it for you. So the failover interface. Okay, so how do we do that? We do that by the command sitting on the primary ASA that we have designated is a failover LAN interface failover. This is the interface name, by the way. Just let me do a question mark here. Failover. So by the way, the interface name, just like a name if of an interface on ASA. So whenever you configure an ASA interface, you have to specify the name, otherwise it won't come up. So now it's specify physical or sub-interface name. Now there is no context-sensitive help here. So it got me confused quite a time. Now what you have to do is issue this show interface IP command on your ASA firewall, whatever the case may be, and your interface's names will show up as interface names are being shown up here. So I just copy this name, Ethernet 2, from here and paste that here. So what I'm doing is I'm designating Ethernet 2 for failover. Let me check. Yeah, okay. Ethernet 2 is for failover. So I've designated this interface 2 for failover. One thing. The other part, this is the second part, you have to configure an IP address, but we don't have to go inside the interface. We have to do it sitting from the global configuration mode. That's a little bit tricky for some guys because guys try to go inside the interface and configure the IP address. Like, oh, let's configure the failover IP interfaces on both sides. No, it happens automatically. You have to do it from the configuration mode. So the configuration is that failover interface. Interface IP question mark. You can see your failover interface link. The name we just specified over here, failover question mark again. It will start saying what is the IP address that you want the primary one to have. Now I have specified over here that the failover subnet that we're going to be using is 172.16.29.0/30. So 172.16.29.1 is going to be used by the active peer 252, and the standby peer is going to be using 172.16.29.2. Okay, whoever becomes a standby is going to be using that IP address, and that IP address is going to be used for replication purposes to and fro. Okay, so because think of it, man. This guy needs an IP address, and this one also needs an IP address. That is the only way they talk to each other, right? the keep lives happen, the replication happens, everything happens once they have an IP address on their interfaces. Okay, so it's imperative that they must have interface IP addresses. Now that is done from the primary, sitting on the primary side. Let me just do a show run failover, and you can see I've only configured these 3 commands. Okay, failover LAN unit primary. On the secondary one, I've configured failover LAN secondary. Now what I need to do, because I've chosen the exact same interfaces on both sides, I just need to copy this command, copy it, and paste it over here. Now you might be thinking, why am I pasting the exact same configuration? Shouldn't the IPs be reversed because you're going on the secondary firewall? It should be reversed, right? But the thing is, the catch is, this is for active and standby units. Means whenever that election happens, whoever becomes this active or whoever becomes the standby will take these IP addresses. Means the active one will take this IP address regardless whoever it is. It could be the secondary unit. Sometimes obviously failover happen. I'll be showing you how failover happens and how these IPs get interchanged. But the thing is, the active one will take this IP address. No, this will be cleared. Bear with me if it isn't being cleared right now. I'll just do some failovers and show you what I'm talking about. Okay, don't worry on this. So this is the subnet mask. This is exactly the same command. Just copy and paste it there. And the other thing I just forgot to tell you, if you have anything configured on Ethernet 2, everything will be, the configuration will be cleared, and the ASA will take care of the configuration in terms of failover interfaces. Now, that failover interface, that's done. You've done it. That has been configured. Now we need to configure the state link. It's exactly almost the same, not exactly the same, but the command is failover link, and I specify the IP address. There's no interface command here. I don't know why. They should have specified some kind of interface command, but no. So I'll say state. I'll name it state, and this exactly same way that I was doing for failover interface. Failover interface. I have to specify the interface name again. So I have this interface over here. We're going to be using Ethernet 3 here, so pasting that over here. The failover link state is the name of the interface. Okay, Ethernet 3. So again, everything cleared. If anything was configured on Ethernet 3, it's been cleared. Now the way the IP address work is exactly the same, apart from the failover command, failover interface. So you specify state. Hang on, let me just type this whole command again. I don't want you to be confused because I'm used to doing this and maybe you aren't. So failover interface IP, do a question mark, and you'll see that interface that we just created for the state link, and specify the IP address. That's gonna be what we defined over here. The state subnet is 172.1630.0/30. So 30/30 means we have only 2 IP addresses. So one will be given to the active one. Well, whoever assumes that role, takes that role, not assumes. 252 standby 172.1630.2. Okay, I'll just do a show run failover again, and to see what we have configured here. We have just configured this command, failover link state Ethernet 3, designating Ethernet 3 as the state link. So I'll just copy and paste that on the secondary ASA. And by the way, these are the only things you need to do on the secondary ASA. On the primary ASA, there may be a lot of other commands, a lot of other features running. So everything will be replicated to this ASA as well. So enter that and copy this command again. Again, don't get confused. Why I'm pasting the same command to the secondary ASA as well, because the secondary can be active or standby. The primary can be active or standby. The state can change. This is only for those guys, I mean, standby will take that IP address, and the primary the active one will take the 30.1 IP address. That's pretty much it. Now, I think we're ready. Show run failover, if I may. Okay, I think I have everything configured. If you were to do show IP on these ASAs, you will find that, okay, IP address, you can see the IP address is set. Show interface IP brief, also you can see over here. Well, actually, it is taken two. One second. Yeah, actually, show failover. Now, because I've set it to secondary, okay, secondary by default wants the standby state, because it's actually what we're trying to do. We're trying to break the tie whenever it assumes the role of it is given the role of secondary. It takes the standby one. Actually, the confusion here is because we use primary and secondary, and we use active and standby. That is the problem. That's why people get confused, and sometimes I also get confused when I'm talking to clients and they're telling me something about their firewall. This is a little bit confusing, but truth be told, just the primary and secondary is just a tiebreaker. Active and standby are the main roles that get switched. Just bear with me like for 10 minutes and you're gonna see what I'm trying to tell you here. Okay, I hope you're not drained out. So now what I'm gonna do is I'm gonna hit the command failover, which will enable the failover feature right now. So first of all, let me show you the show interface IP brief. You can see that this guy has taken these IP addresses, which are the active ones, because I've set it to primary, even though they haven't actually talked to each other yet. They haven't actually detected each other because I haven't issued the failover command, but they're still taking these IP addresses because by design they should be assuming the primary should be assuming the active role, and the secondary should be assuming the standby role. Failover. So I'm triggering the failover on both ends. Now they're starting to, okay, there it is. No mate detected. I think sometimes this happens, like the secondary has detected an active mate. Okay, so this is a problem. I did not had 8 interfaces on this ASA, and it's prompting me for errors right now. But I guess it's fine because crash info is not in the middle, end of configuration from mate. But we have that ASA configured now. Straight away, you can see one big thing. Its ASA name was Cisco ASA, and the ASA name changed automatically to the one that the primary one had. Lovely, isn't it? So the name has changed. So if I do the show failover, you can see this host is primary. This is the one I was talking about. The primary is the priority that I've set, and the state is active. Now you get it? The other host is secondary because I've configured it as a secondary, and it should be standby ready. It's doing some syncing right now. The configuration, do this a couple of times. Yeah, there it is. So now you can see this is secondary and this is standby ready. Ready means it's ready to take over to the active role if the firewall goes active firewall goes down. Now immediately when I configure failover, I do one thing. Without that command, there's a lot of problems. You see, if I were to see both the firewalls somehow SSH to them or telnet to them, whatever the case may be, a console to them, I see the same names on both of them. Now if I were to look at the show failover command, show failover on the primary one, I can see, okay, this host is the primary. Okay, so I say, okay, this is the primary one, and this is right now in the active state. Okay, now I get it. Which firewall is it? But in production or anything like that, you get confused. You don't want that to happen. You need a prompt saying that, hey, this is the primary firewall with the active role as of right now. And similar will be the case with this one. If I were to do a show failover, then I can see that, okay, this firewall is this host is secondary, okay, this is standby, it is in standby state. So I don't want that to happen. I want a prompt telling me that, okay, this is the primary one and the active one, or the standby one, whatever the case may be. How do we do that? So it's done with the command. Now everything I will configure from here on out will be done on ASA 1, because that's the active as of right now. Whichever one is the active, I have to configure it on that. If I try to configure it on the secondary one, it will say a warning: configuration replication is not performed from standby unit to active unit. So whenever you're doing configuration on the active guy, this guy over here, that won't be replicated to the primary, the standby guy. Oh, sorry, what am I doing? I get confused. This is secondary and this is standby. This is primary and this is active as of right now. Now, in the secondary one, if you do any configuration changes, it's in standby as of right now. The standby won't send the configuration replication to the active one, okay? Because active one should be the one doing the configuration changes, okay? So that's why I did not get an error when I did a configuration terminal on this ASA, okay? Okay, the prompt command, this is the one, prompt, and host name, show me the host name, the priority, this is what I was talking about, priority, and the state. Okay, now look at that. Isn't that beautiful? What you're seeing now is these three things, and it's pulling out from the failover of the ASAs. It's saying, okay, what is the host name of the ASA? Obviously, it's going to be the same between both the ASAs which are in failover pair. The PRI means primary, that's the priority that we set as an administrator, okay? And the state as of right now is active, that is shown by ACT. Hopping on to the other firewall, look at this magic. Oh, lovely. Isn't that lovely? So ASA DC, this is the host name. This is the secondary, the priority that we set as an administrator, and the state as of right now is standby. Beautiful, isn't it? Now, just to show you how this can change, I'll just issue one failover command. Now you can actually, as an administrator, failover the firewalls whenever you want to. So it is done with the failover command in privilege mode. So if you do a failover active, this command, actually what it does, it says that if I'm in the standby role, I want to become active. This is what this command does. So it's already active, so this command has no meaning right now, okay? But if I negate this command, saying that no failover active, it's the reverse of that. Failover active means I want to become active from the failover pair. You can put this command on the secondary and that will work. But if I'm sitting on the primary one and I want to let go of the active role, so I will just say no failover active and switching to standby. Look at that. I just love it when this happens. And check the states now. It is still primary because I configured it to be primary, right? So the tiebreaker was there. But as I have switched, now I'm in standby state. You see how the state actually changes. Okay, so if I do a failover active command right now, it will assume it will take the active role again. So switching to active, it's just been activated. No timers, nothing, no downtime anywhere, okay? Similar is the case if you want to do it from here. So you could do a failover active and it takes the active role. This is the secondary one. And you want to get rid of that role, so you do no failover active and you switch to standby again. Pretty cool, huh? Okay, so we have configured the failover as of right now. Now we will go and look how we configure the data interfaces, both from our inside perspective and our outside perspective, and what actually happens in the monitoring sense of way. Okay, so it's time to configure the data interfaces, as you can see over here, on the inside and the outside. So let's hop into our firewall and hop into our interface Ethernet 0. I'll say name of the interface is inside, sorry. Set it to security level 0. So because I misnamed it to inside, I didn't specify the E over here, so that's why it changed the default security level to 0. So I can change that security level to 100, and no shut the interface. Now, when I'm given an IP address, I can give an IP address like this: 10.1.1.10.255.255.255.0. So the warning says that failover is enabled, but standby IP address is not configured for this interface. Now, what does that actually mean and specifies? Is that I've configured an IP address over here, and when this ASA goes down, this same IP address will be automatically configured here, and gratuitous ARPs will be sent out on the network, and the network will know that this ASA now has this IP address. But the problem here is that we won't be sending out any keep alives or receiving any keep alives on this interface. So what's the problem now? The problem is the only way the ASA can trigger a failover is only if this link goes down. Now, before I get deep into this, you must know that an ASA can have multiple interfaces. You can have sub interfaces like VLAN interfaces, physical interfaces, and all of them, which are physical, have monitoring on by default on them. Means the ASA actually monitors these interfaces, and even a single interface, if it goes down, the ASA will failover. This is the default behavior. You can actually amend this behavior to specify, okay, 50% of the interfaces goes down, then I only want this to happen. Or if the outside interface goes down, then only I want the failover to trigger. What actually specifies an interface going down? Now, here's the problem. When I have only one IP address set and without the standby IP address, I cannot send keep alives, okay? So, as I told you, if this link were to go down, the line protocol goes down, only then this ASA will know, hey, this interface seems to be down, I should trigger the failover now. Now, in today's networks, this isn't going to happen really easily. Some administrator could come here and, he's configuring something here, so maybe a switch or something, and mistakenly he in the range he added this interface and changed the VLAN from 10 to like 11. Now straight away, what's going to happen? The data users that were coming in from this interface won't be able to go here because the VLAN obviously is not the same as VLAN 10. Okay, it should be in VLAN 10 for the users to actually communicate with this IP address, which is the gateway configured for this router as of right now. So you see where we're going now. Without the keep alives, the keep alives are sent this way. It goes to the switch and goes to the other firewall and receives the keep alive, and that secondary also sends keep alives, goes to the switch, and the keep alives are received on the primary ASA or active standby, whatever the state may be. So you get the point. If something were to happen on the network, some misconfiguration, or you mistakenly, configure an interface, misconfigure an interface, the ASA won't know that this link is no longer usable right now because I cannot reach the other firewall via this interface because my keep alives are not going through, and I'm not receiving any keep alives, obviously, because the VLAN has changed over here, or something has happened over here. So it doesn't use the network to actually monitor this link, this inside link. So it's imperative, I believe, that you must have the standby IP address configured. So let's go there and say, actually, let me show you the Wireshark capture here real quick, since this video is getting long. So I believe it should be detailed, right? However much I can make it detailed. Now I'll just leave the Wireshark capturing enabled over here. Yes, I just hope I don't get any blue screen errors, because I did get an error earlier when I was testing this lab. Okay, so let me just do. Okay, so as you can see, only spanning tree packets are coming in. You don't see any keep lives or anything coming from the ASA, because obviously nothing is configured on the secondary one. So the command that is recommended, even though you can start your failover and everything can work with this IP address only, but you should have the standby IP address also configured that will be taken on the standby interface of the secondary firewall. It's going to be 10.1.1.20. Oops, sorry. That's not what I wanted. Here. So this is the interface that should be configured for keep lives to work, because obviously, if you look at the TCP/IP stack, for them to talk to each other, they need an IP. I mean, they could have talked on a layer 2 if they would have programmed them that way, but they haven't actually. They need IP address to communicate back and fro, because they use IP protocol 105 for keep lives and stuff. Okay, if as soon as I hit enter, look at what happens on the Wireshark. Here are the keep lives now starting to come up. Okay, from keep lives from 10.1.1.10, that is ASA 1, and 10.1.1.20, that is ASA 2. And you can see they're working on protocol, IP protocol 105, SCPS. Okay, not going into the detail of that, but these are keep lives, okay? Now, once the keep lives are, they're getting the keep lives back into, oh man, to and fro, they're getting the keep lives. Now they have a very good understanding of the network. They can reach each other from this inside interface, so they can make the triggering decision more accurately, right? This is why that standby IP is really important. Otherwise, you're reliant on only line protocol, and that happens mostly if you unplug the cable. That's it. You won't have any understanding if any VLAN has changed or something has changed in the network and your firewalls are affected by it. Okay, so similar we'll be doing for the outside interface Ethernet 1, IP address 20.1.1.10, 255.255.255.0, standby IP address of 20.1.1.20. Sorry, yeah, okay, 20. So I'm not doing any captures on the outside switch, but let me show you that. Show failover. If I were to do that, you would see now we're beginning to see interfaces as well. I'm not seeing the outside because I haven't shut that interface, that's why. But take a look at this inside interface. It says it's in a normal state and it's monitored. Monitors mean that it's in monitoring, means if it goes down, it will trigger a failover. Now you can actually amend this as well. You can make an interface not monitored if you want to. If I were to go into global configuration mode and hit monitor interface inside, no monitor interface inside. Now what it will do, if we were to look at the show failover, now it says not monitored. That means if it goes down, there are cases actually. If this interface, if I'm sending keep lives and all of a sudden something happens over here, something bad happens on these interfaces and VLAN misconfiguration or something, and I don't get the keep lives, I will, the state will change that I'm not getting any keep lives. There is a problem with that interface, but I won't trigger the failover and make the other firewall the primary. The active one. I won't do that. That is one case. Or you could say that, okay, I could actually go in and say, first of all, I'll just enable the monitoring interface that I just disabled. Show failover. Now it's in monitoring state, and it's waiting to be active is normal. So one of them is now in monitoring state, and the other will be soon in monitoring state. Okay, both are now monitor and normal state. state. Sorry. Okay, if I were first of all, let me just no shut that interface, that outside interface that I configured over here, Ethernet 1. Ethernet 1, I didn't no shut it. Do show IP interface brief. Oh shit, sorry, interface IP brief. Now it's in upstate, but I don't have any IP address configured. Really, I think I did configure the IP address, didn't I? Show run interface Ethernet 1. What's up with that? Oh, okay. I actually didn't configure name of the interface. That's the first problem. It automatically will choose the security level 0. Okay. Now it's working. Now it has taken the IP address. And by the way, if you were to hop onto, you see things are happening over here. You can see the logs that, okay, inside interface was configured and all that. So if I were to show interface IP brief on the standby one, you will see it has all the secondary IP addresses that I have configured. Okay, so now show failover. If I were to do that, you see both of them are coming into monitoring state. Let's just wait for them to come into monitoring state. Now, if one of them has to go down, I mean, some reason happens, the failover will trigger. But there could be an instance where I say, okay, if 3 interfaces or 4 interfaces go down, only then I want the failover to happen. So that is done by the command failover interface policy. Policy. Now there are 2 ways you can actually specify this policy. Number of fail interfaces means you have 10 interfaces. If you have 10 interfaces and you want, okay, if 5 of them go down, then only I want the failover to trigger. I don't want it to be triggered if only one interface goes down, which is a default, by the way. Or if you have tons of interfaces, sometimes you have these logical interfaces like VLAN interfaces and they span a lot, like 50, 60, something like that. Then you can also specify the percentage if you want, like 10% of the interfaces go down. 10% of the interfaces. If 10% of the interfaces go down, then only I want the firewall to trigger a failover. So let's just put it to default. I don't want this to be like 10%. Nor I want only 5 interfaces to go down, because that won't even trigger the failover. You see where I'm going with this? Show failover again. And both of them are in monitoring state. Okay, now let's do some traffic pings and everything. So for the pings to happen between inside router and outside router, first of all, ASA has some things that we need to take care of. First of all, I need to create an access list. Access list permit, I'll call it permit all. Permit IP any. Don't do this in production. I'm just doing it for this lab. Access access group permit underscore all global. Just globally applying this access list, so everything is permitted now. And one more thing, because we're going to be using ICMP, it does not inspect ICMP by default. Show run. I'll just show you. Actually, this is a very good command for you to know, because firstly, when I was configuring ASAs, I was like, why aren't pings going through? So it turns out the default inspection does not have ICMP enabled for inspecting ICMP, so that's why that was happening. So if you were to do these 2 commands now, ICMP should be allowed. Otherwise, we'll do troubleshooting. 20.1.1. Come on. And oh yeah, great, that's working. So we have communication going from the router in router 1 to out router 1. And from where are we actually going? Well, let me just show you what is happening behind the scenes. is that I have an ARP table on the router, on the switch, sorry. Show MAC address dynamic. Now just take a look at this MAC address table. Now this MAC address is of ASA1. So if you were to look at the topology, we can see, okay, this is connected to ASA1, which is the primary and the active as of right now. Okay, and the BBBB is coming from gig 0/1, which is connected to ASA2. Okay, that is the ASA2's interface MAC address. Now, once we have a failover triggered, what actually happens? Let's first look at the router, show IP ARP, because it has some ARP table as well. Now, to reach 20.1.1.0, I have a route configured here. So include IP route, simple static route I have configured. Okay, over here. The next hop is this. So next hop is obviously on my same network. So I've resolved it. The ARP binding says it is going towards AAAA. If I look at the MAC address table on the switch on the inside, it is showing me I'm learning the MAC address from gig 0/0, which is fine. Now, if I were to trigger the firewall right now on the failover, check what happens. Okay, let me show you a Wireshark capture as well, if I'm not already doing this. I don't know what, from where I'm doing this. Let me just quit this and do a capturing from gig 0/1. Okay, just to show you the ARPs that come from the secondary ASA. They're gratuitous ARPs just to make the topology point towards the ASA2. So I'll just be filtering on ARP only, okay? And minimize that. Now let's just trigger a failover, like no failover active on the primary one. So switching to standby. Now you have seen this MAC address table, right? I'll just press up arrow enter, and now you see nothing has changed on this side, MAC address side, but check on the ports. Firstly, I was getting the same MAC address, the 4A's MAC address from gig 0/0, and now I have changed it to gig 0/1. Now because of this, look at this. I got these gratuitous ARPs coming in from, this is coming from what interface? That interface of what do you call that? ASAB, the secondary ASA. So I got these gratuitous ARPs coming in. Once I have these ARPs coming in this interface, the ARP has a source MAC address, right? So check out the source MAC address of this gratuitous ARP. The source MAC address is 000, all zeros and it's triple A's, no 4A's. What does the switch do when it sees a source MAC address? It actually, changes its MAC address, its MAC address table. It updates its MAC address table, right? Its CAM table is updated. So now the CAM table is updated to go from gig 0/1. So no problems actually occur in the network because of this scenario. This is always what happens when we do a failover on the ASAs. Now let's do the failover again. Let's put it to active. Oops. Failover active. Okay, now it's switching back. Just check this out again. Beautiful, isn't it? Now the same MAC is being learned from gig 0/0. Okay, before I trigger the failover in real time right now, let me show you something. Let me just telnet from inside router to telnet to 20.1.1.1, and I'm actually telnetted to out router because I already have transport input connection configured over there without passwords. So now let's just hop onto the ASA and say show connections, and now we're talking about the state table that we were saying that this is the state link that we have configured. Now this is a state table that we see, okay, for our TCP body from our source of 10.1.1.1 from this gigantic source port number going towards 20.1.1 on 23 means telnet. Now if I were to do the show connection on the standby unit, I can also see that the same connection table is also here. So that means if the firewall were to go down, means I would change it right now. I'll just no failover active. I'll do that. You see, nothing happened here. It didn't even know, okay, because the other firewall had that state table already inside of it, so it didn't have to reset the connection, or it didn't stall or halt over here. The telnet connection that I was making from the in router, it did not happen. So this is the beauty of the state table, man. I mean, I'm a really fan of state table. So this is how it actually works. So I'll just do failover active. Okay, so it's standby again, and still everything's working fine. Now to actually show you, I want to show you how it actually works. I'm not going to leave you guys that easily. So show run failover. Just going to remove that failover command that I had over here. I'll just say, I don't want the state link. I'm disabling that, okay? But I'll keep it somewhere, okay? I'll keep it so that I can apply it again. Now, if I do a show failover, I don't have any stateful failover logical update statistics anymore. Now, let me just do an exit. I'm just terminating the telnet session from in router to the out router. Now I'm doing the telnet session again. Okay, so I've telneted to the other router. Now, let me check this. Show connections. It may have the older connection. Let me just do this. Let me exit this again and clear the connections because it had a timeout actually. Show clear connection. It's already done, I think. Yeah. Okay. Now let me see if I have any connections. Show connections. No connections. Show connections. No connections. Okay. Do a telnet again. Telnet it. Show connection on the primary one, the active one. I see a connection. Okay. On the secondary one. Oh, come on. Show connection. I don't see any connection coming in. Okay. That connection is not being replicated here because we don't have a state link. Now, let's see what happens when I do a failover right now. This is a moment. I haven't actually tested this, but I'm testing it live now. I mean, in recording. Let's see what happens. So I'll just say no failover active. This is going to be fun. Oh, look at that. Yes. The theory has been practicalized. I don't know what that means, but yeah, that worked like a charm. You see what happens? You see what happens? That's why you need the state table. If you have an RDP and there are tons of RDP connections going on, or I mean, with HTTP and browsing, you won't feel a thing, because they do all the retransmission all the time. But RDP is crucial, right? Sometimes you have some data coming in, going out, and you're configuring something really important, and something comes up, and the system team will say, "Hey, because of you, network guys, this happens to us all the time." So that's a fight that you don't want. Failover active again. I'll activate that. I'll just put the state again. State. Where is it? Okay, this guy and the state link here. Okay, now it's time to actually test the failover, and there are some timers that you need to take into consideration. For example, if you're testing failover, you normally what you do is you would just reload one of the firewall and see what's going to happen. It's going to take some time. Now, if the interface has some issues, the interface, like this interface, has some issues. Ethernet 0, so something is misconfigured on the VLAN side or on the switch side. Anything goes wrong, and the keep lives are amiss. That takes a little bit more time because it has to do some testing on the interfaces. There are some phases which you actually have already in place. Again, not getting into the details of that, but you have to take this into consideration that maximum, if you do a reload, which I will do right now, it can take up to 45 seconds for the firewall to, fail over to the other one. And if there is an issue with the interface, like, look at that, active interface is up, but connection problem causes interface testing. Because it tests the interface, this could take up to 75 seconds as well. So you have to be mindful that it doesn't happen like a split of a second. It could happen in 2 seconds if you have a unit with firepower module inside of it, because if the module fails, the firepower module fails, it's sitting there in the hard disk. Okay, both the firewalls can talk to each other. They can, via the failover link, they can tell each other, hey, my firepower module is down. So they immediately trigger a failover. So these are some of the timers that you should take into consideration. Let's just do a reboot and see what happens. I'll just do a ping. Sorry, I was just testing some things actually. So I would do a ping from 10.1.1.1 to 20.1.1.1 and repeat that 100,000 times. So I'm pinging from router in router to out router. Okay, so that's happening, and this is all going through firewall 1 because that is the active firewall as of right now. Now let's take a stopwatch real quick. If you have nope. Well, let me just open a browser and put a stopwatch here. Stopwatch. Oh, sorry, I don't have internet. I have some problems with my internet service providers, so I have some problems. Okay, we can determine the time from here, but check this out. I'll just put the time in my mobile. Wait a second. Okay, there it is. I'll just put the stopwatch over here. Now we're just going to be reloading this firewall. Start. No, sorry. Stop again. Reset that. So configuration has been changed. You have like modified. Sorry. Reload. Confirm. And 1, 2, 3. The timer has been activated, and pings are being dropped. 5 seconds have passed. 10 seconds have passed. 15 seconds have passed. 20 seconds have passed. 25. 30. 35. It should come up, I think. It's taking a lot. Oh, okay. Round about at 37 or 38 seconds, it came back. It failed over. Okay, let me check the documentation again. So, you see that maximum 45 seconds. Okay, so that did happen. So almost we were hitting this 45 seconds line. Now, once, okay, let me just get this ASA back up, and we'll continue on from there. Okay, the firewall is back from the reload, and it's in standby state as we assumed it would be. So the switch it to active, failover active. Okay, switching to active. So now what I'm going to be doing is I'm going to change the interface configuration over here. I'm going to change this interface configuration I'll just change the VLAN from 10 to 11, and let's see if this one is really what it is. I mean, it takes 75 seconds at most. Let's see how much time does it take. Okay, so going to that switch, I'll say configure interface gig 0/0. Let me check if that is the interface. Yeah, that is the interface. So let me just get my stopwatch running again. Wait a second, reset that, and okay, okay, shut, no, not shut, switchboard access VLAN, I'll say 11. And wait a second, I need to put some pings over there, and boom, timer is on. Now you'll see pings are being dropped because I've changed the VLAN. It should be in VLAN 10, but I've changed the VLAN to 11. That is causing it to put the interface in a test situation. So if I were to do the show failover, it's now in testing state because something is happening wrong. The keep lives have been missed between the firewalls, and we should keep our eye on this guy for the time being. And just want to show you how it's all working out. So it's showing as failed. Okay, the interface has failed, and voila. Okay, that takes for 45 seconds, so almost the same, right? It was almost the same. So if I were to show you switching standby, so show failover, if I were to see show failover, you can see that this host was a primary one, and it failed because one of my interfaces has failed, and it has switched to the secondary one, and that is now the active one. Okay, so this was the active standby failover for the ASA, and I think this has been a long video, which I firstly didn't thought it would be this long, but we tested a lot of scenarios. Now, if you like this video, hopefully you will, because it's an extensive and a big video. If you want multiple context firewall failover, I can do that in the same way I have done this one. Again, this is all for you guys. I'm trying to put my knowledge out there for you, to make things easier for you guys. I mean, that's what I want, actually. At the end of the day, that is the main reason I'm making all these videos. So I'm putting a lot of effort into this. I hope this has been informative for you, and I'd like to thank you for viewing.